Hi, this is the second question of the paper June 2014, C34. The question is, a curve C has the equation x cubed minus 3xy minus x plus y cubed minus 11 equals 0. Find an equation of the tangent to C at the point 2, negative 1, giving your answer in the form ax plus by plus c equals 0, where a, b, and c are integers. Now, to do this question, first we have to find the gradient of the curve at the point 2, negative 1. The gradient of the curve will be equal to the gradient of the tangent, which we can use to find the equation of the tangent. So first, to find the gradient, we have to differentiate this equation of the curve. So I'm just going to write diff with respect to x. So the first term, which is x cubed, will be 3x squared. And the second term will be differentiated using the product rule because it's 3x times y, so it's a product. So what we can do is, we have to put this in brackets because we have a negative sign here, and if we don't put this in brackets, then we might make mistakes. So it's 3x times the differential of y, which is just 1 times dy dx. So it's dy dx plus y times the differential of 3x, which is 3. And then close the brackets. The next term is y cubed, which is, if we differentiate it, we get 3y squared times dy dx. And then negative 11 is just 0, so equals 0. Now, expanding this, after expanding this, I'm going to get 3x squared minus 3x dy dx minus 3y plus 3y squared dy dx equals 0. I'll put the dy dx terms on one side and the rest of the terms on the other side. So I'll have 3y squared minus 3x, and then dy dx is common for them, equals, wait, I missed a term here, I think. Yes, I did. We have negative x also, so when we differentiate negative x, we get negative 1. I did not put that in the equation, so we just have negative 1 here as well. So we have 3y, yes, 3y plus 1 minus 3x x squared. So basically it's these terms which I brought on the other side. This one, and the negative 1. So 3y plus 1 plus 3x squared. This is x. Okay, 3x squared. Now, the next step is to write dy dx equals 3y minus 3x squared plus 1 divided by 3y squared minus 3x. And at the point 2, negative 1, dy dx equals so in place of y, I'll write negative 1, and in place of x, I'll write 2. So it's 3 times negative 1 minus 3 times 2 squared plus 1 over 3 times negative 1 squared minus 3 times 2. And what I get is 14 over 3. Now what you can do is, you can directly substitute the values of 2 and negative 1 after this step as well. So you can do that in this step as well. So you don't have to make dy dx a subject, because once you substitute the values in, you can just keep solving and you'll get dy dx as a subject and get the value of 14/3. But I prefer it like this. Whatever you find easy, you can do it that way. Now, we got the gradient of the tangent. which is 14 over 3. Just make sure that you have to find the equation of the tangent and not the normal. Go back to the question at this point and check. So it is the tangent, so find the gradient will be the same. Now, the equation is given by y minus y1 equals m times x minus x1. So y minus y1 is -1, so it's just y plus 1. M is 14 thirds, and then x minus 2. I'll multiply both sides of the equation by 3, so it will give me 3y plus 3 equals 14x minus 28. Now writing this equation in the form ax plus by plus c equals 0 gives me 14x minus 3y minus 31 equals 0. So that's the equation. And the terms a, b, and c are integers. We have 14, -3, and -31. So yeah, thank you for watching.